Get started. This is the working session of the Data Fabric Interest Group, and it's for years been called the Data Fabric Interest Group. We are talking with RDA about a name change to really fit more of what the group focuses on, and that's really the digital object fabric. We've known the general. The name has caused some confusion in the past. We're working with RDA, as I said. We've made that formal request to change the name of this working group to the Fair Digital Object Fabric Working Group. We want to keep fabric in there, but we think that this is a better name for that. So if anyone thinks that a name change is inappropriate from the group, please let me know if you have other ideas or changes, but I think that this is what will be called moving forward, so people will have a better idea from just the name of what we're actually talking about. So if you could move forward, please. Reiner, can you move to the next slide? There we go. So the group has existed since P4, so we've been around a long time and are very much a long-term group. We're really concerned with that cross-group discipline infrastructure challenges, so the challenges of creating an infrastructure to allow fair digital objects. One of the things that has changed between P16 and P17 is that 2 of the 3 chairs have left, and we've brought in 2 new chairs. I think Reiner was very much acting as a chair by the time that we hit P16, but officially it has been changed, and the co-chairs now are Xin Chen, who has replaced Jianwei, and then Reiner is replacing Tobias on the European side. So our new chair lineup is Xin, myself, and Reiner. And we really want to promote a creation of an ecosystem that has components that are reusable and approaches. So this infrastructure needs to be reusable by multiple groups. And really it's based on the digital object architecture and PIDs as foundational technologies, which we'll go into more. And we also are, of course, leveraging the FAIR principles as many groups are. So next, we will, real quickly, I didn't put times on these because I think they're a little bit open. We'll do an introduction, which we're in now. If Xin has joined, we'll have her do a intro as well as Reiner. Then we'll have a talk from Larry about the digital object architecture and some discussion on Larry's presentation. Then we'll have a video presentation by Luis talking about the Fair Digital Object Framework and a little bit about linked data. And then we'll have a discussion of that presentation and then possibly bring it all together into a final discussion and wrap up and talk about our monthly meetings and action items that come from this group. So I think I have one more slide and then we'll get into the intros of the new chair. I don't have another slide. Did we miss a slide? Anyway, we can move on. I thought I had one that talked a little bit about some foundational documents, but I may have edited that out of the this presentation. So moving forward, Xin, have you joined us yet? Okay, if Xin hasn't joined us, then Reiner, do you want to do a introduction of yourself and your work?
Yeah, Xin has sent an email that she won't be able to join the session. Oh, just make it quick because most of you already know me. I'm Rainer Stotzka from Karlsruhe Institute of Technology in Germany. I've been with RDA, I think, from the very beginning. The first or the 0 meeting was in Arlington when we first met, which was really, really fun. It was a really small group, and I joined RDA because interoperability is one of the big topics, especially for me, technical interoperability. And this is also one of the reasons why I love here this IG Data Fabric or the future IG Fair Digital Object Fabric. And I will be happy to contribute. I think we have to make this concept visible, and we have to bring it into implementation and into the communities. And especially for this group here, for our IG, which is a communication and coordination group, I think it should be attractive. It should be attractive for everybody to join. And this is one of the key things to make it successful. So this was my little commercial. Back to Rob.
Thank you, and I'm going to pass immediately to Larry to get into the subject matter at hand. Larry, if you want to take over. Larry's going to talk about the digital object architecture. We've worked together for quite a long time now, and he always gives a great introduction to the architecture. So, now we got a
yeah. Thanks, Rob, and you gave me sort of too much of a lead-in, so I hope I don't disappoint. So, hello everyone, Larry Lanham, CNRI. Many of you have seen my talks before. This one is a little different. I always try and do something a little different. And I'll start with a couple of slides about the problem. I think we all pretty much understand the problem, but I'd like to remind us all of why we're doing this. So DOA, Digital Object Architecture, is trying to solve a general problem. We have enormous increases in computing and network capacities that should make more data available for more purposes to enhance the common good. But in fact, while this has happened in some areas, it's pretty suboptimal. We have overwhelming amounts of data. We still have systems that are oriented to us slow humans who will never catch up. We can't make sense of millions of items of data. We don't have the capacity to do that. We need help. And opacity also makes the common good elusive. Who has the data? What are they doing with it? And the fragility of complex systems, and they do get complex. We have millions of APIs and lots of places to store things and old data and new data. That leads to security problems, to things we're all too familiar with. This is all true in its own way in research data. We should be able to make data and methods directly available instead of historically what we do, which is just the results. And that should lead to increased trust and reuse. But we have great fragmentation, domain and lab specific silos. Data is known to the people who produce it and less well known, less understandable to the people who did not produce it, which means that interoperability remains quite elusive and a big problem. This has led to a reproducibility crisis, funding issues. How do you deal with all this data? Who gets credit issues, something that RDA addresses. And in general, more time than we want spent on data than on science. Now, the FAIR guidelines address these issues. It's one of the reasons they've been so popular. And they're oriented more towards machine actionability and so on than most people realize, I think. They've taken on sort of an ethical connotation, and that's true, but it needs to be extended beyond that. It's been applied to publications. From my perspective, that's low-hanging fruit. Those are the easier things to make fair. The lab work remains a great challenge for FAIR, and we have to get down to being fair at the data source. As an example, workflows. In general, we need to turn this challenge into an opportunity. We need to go from too much hard to use, hard to find, hard to understand data to lots of accessible and understandable data. Okay, that's, again, I like to remind people of this. That's why we're doing this. It's important. So how does digital object architecture approach this, both the general and the research data problems? It's by adding a level of abstraction to current information management systems. Now, that abstraction is frequently used. If you think about it, it's the way humanity has addressed complexity for a long time, starting with accounting systems, numbers. Instead of having to bring 200 goats to a meeting place, you bring a piece of paper that says you own 200 goats. We need to apply that kind of level of abstraction to our current set of problems. For basic information management tasks, our goal is to make every object be treated the same, regardless of information content. There are multiple parallels to this principle in computing now. One of the most common ones is the file system. Your applications, Word or Excel, they don't need to understand how the file system works. They just need to tell the file system they need a file, and then they can deal with the file. The file system and the operating system take care of where all the bits are stored, and nowadays they might be stored anywhere on the planet. You have to segregate those concerns to be efficient. The internet works on a similar principle. Every packet is routed in the same way. We don't have to look at the packets to move them around. There's great leverage in that. We worry about the packets only when they show up at the end and the applications then open them. We want to do that with information objects. And to do that with information objects, we need to establish a common level of abstraction where every object can be treated the same. Every object has a unique, globally unique and actionable identifier. You can't manage something unless you can reference it and name it. Every object is typed. You have to understand what sort of object this is. There's a parallel there in file systems with MIME types and file extensions and so on. Every object has tightly associated metadata. Again, there are parallels all over the place. And every object has a queryable set of operations that can be requested of it. Here we begin to go beyond the analogies I've made before, but this is an important part. We need to be able to call these objects into existence with their name and then talk to them and find out what they can do for us, which means we need a protocol, and that's where the digital object interface protocol comes in. We need a common protocol to address these information objects. So what's the roadmap? Well, we have to start with the minimal set of components and services that enable this. You always try, in building infrastructures, you cut away and cut away and cut away until you get to the features that are absolutely needed, such that you cut the next one, the infrastructure breaks. You don't want any more complexity of the infrastructure than you can get away with. And that's identifiers plus a resolution system. Again, you need to be able to name things in order to manage them. You need types and type registries because you need to understand what kind of object this is once you retrieve it. You need repositories, which I'm trying to convince people to call object servers, but I seem to be losing, including repositories of metadata, which we call registries. That is, the collection of bits that form a digital object is, of course, just a collection of bits. Something has to act on them. And that's the job of the repository or object server, which itself is an object. And then you need mapping and brokering software and services to map existing data storage management systems to a digital object layer. This is the hard part. A tremendous amount of work involved in there. This is not easy. And the existing information management systems are not going anywhere. We need to accommodate them. There's a parallel here with the creation of the internet. The internet was not the first computer network at all. It was just the first computer network most people knew about. So the initial router, which was called an IMP at the time, was just to connect existing networks, not to create new networks. Over time, then those networks became ever more compatible. But you can't assume the existing stuff will go away. And we need an interface, digital object interface protocol, which the repositories would implement. That is, that would be the way to talk to repositories. And then open the environment to as many use cases as possible. All right, so why is this a good idea? It simplifies the solution space. Again, treat every information object the same until you have to differentiate among them to accomplish your purpose. Push the current cacophony of information management and storage systems down a level of abstraction. We don't, like files, we don't have to worry about where the bits are. We don't have to understand the file system. We just have to be able to use it. We want to apply that at the network. We want to apply that at the internet level. We want the internet to be a collection of digital objects which are uniformly addressable. And then we do the hard work once we get hold of them and can compute with them. And the objects have to be self-describing in that they carry their type and access control information independent of their current system location. Think about access control. Most access control is governed by the system that the information is embedded in. Be it a database or a file system. once that information leaves that environment, it no longer has any access control indicators. That information needs to travel with the object. The implementation will depend on the server that serves it up, but the information has to be in the object, embedded in the object. So what would such a digital object look like? So here we'll build one, virtually speaking. So primary content, assume a data held in matrix form. We have to associate with it an identifier, types, metadata, related links, access rights, operations, and so on. Stick it in a repository that understands this structure, even if that's a mapping from some other structure down below it. We need a module that talks digital object interface protocol to the outside world, and a module that translates that into its own local communication channels. So those clients up in the upper right don't have to understand any of the structure below. They just have to be able to talk a protocol, and the repository takes care of answering in that protocol. So here's an example of some operations. So now we've taken that repository, shrunk it up a little bit. It's lower left. We have some users, some clients, which would be people or more likely computers, independent people for a while. When we have some cloud-based stuff, federated set of type registries, and some services. So we're assuming an identifier is in place already. So digital object 1, 2, 3, 4, 5, 6, use the digital object interface protocol, tell me what I can do with this. The repository knows by looking at the object, identified object, that it is of a certain type 8286767, goes to a federated set of type registries. What sort of operations are enabled for this? You get back a bunch of remote services information in this example. You let the client know that there is an operation 345989, that's the visualization of the digital object. The client requests that. The repository requests the service, gets back the answer, or sends the answer directly back to the user and sends it along. Visualization result. That would be one example. Once you establish this general framework in which objects are typed, identified, and associated with services, you can imagine a lot of different things could work in that way. So do we have any examples? Well, we do. So here, compliments of Alex Hardesty, is a sample digital specimen object. This is what it would look like. This is a digital twin, if you will, of a physical specimen held in the French National Natural History Museum in Paris. It's a cone snail. There's a picture of it. It has a local identifier. It's a mollusk. It has an identifier for the object, which is different from the identifier for the physical specimen. It has a type. It's an open digital specimen that might get specified later as Alex and comrades get deeper into this issue. It has metadata. It has a scientific name. It has a certain size. It came from a certain place. And it has links to things like maps, where was this found, and DNA information, and a zillion other things. That's the sort of detail that would be specific to domains, and for which the framework will have to enable lots of variation. Now, who's looking at all this? Well, there's a Fair Digital Object Forum. That was got going a few years ago when the Go Fair group saw digital object architecture as a promising implementation. There was a meeting in Paris in the fall of 2019, which yielded a joint statement on the Fair Digital Object Framework. It's a notion of the way we were, a variation of what I just showed. This was quiescent during the pandemic, but is recently rejuvenated. Peter Wittenberg put a lot of energy into this. The goal is to coordinate efforts and encourage use. And I hope the Data Fabric Interest Group and its future incarnation will be part of this. There's a steering committee now and working groups now. These are just forming. This is all quite recent. And we're trying to produce some core specifications as an early output. There's a website, fairdo.org, compliments of Dimitri Kurius, many of you know. It's just now being populated, so it's in motion. And we're planning a conference, the first International Fair Digital Objects Conference. We were going to have that earlier, and of course the pandemic has gotten in the way of a lot of things. We now hope it'll be the spring, 2022. It'll be somewhere in Europe. The leading contenders at the moment are Leiden and Göttingen. So, and as a segue to the next talk, which I understand is a video, this was sort of the general notion that we take the FAIR principles, the work that's been done on semantics. The digital object architecture does not address semantics. It's a framework. It doesn't address semantics any more than a file system or the internet addresses semantics, but it gives you a framework and a set of tools which you can plug in semantic computing and algorithms and the digital object architecture. And the result of that will be the core FAIR digital objects. And that's my slideshow. And I think now I have to stop sharing. And I'm still here for another 15 minutes or so. Unfortunately, I have to leave early, but we can take any questions if this is appropriate, Rob, or you want to wait till something else happens? No,
let's definitely take questions now, one while you're available, and we also scheduled 15 minutes after your talk for discussions. So we would encourage people to unmute and turn on your cameras if you'd like to ask questions. There was one in chat from Stian asking if HTTP was a common protocol, and I think this came up when you were talking about DIOP being a common protocol. So
yeah, DOIP has a native implementation, bits on the wire, but it also has an HTTP tunneling sort of thing. That is the important thing, and I should have given a link or so. It's a DANA, the Digital Object Naming Authority, it used to be called. Now it's a Swiss foundation that's responsible for that. And they have published recently, maybe a year or two ago, the second version of DOIP. It's a very abstract protocol. And then there are some implementations. But as an abstract protocol, it just means you can ask certain questions and get certain answers back. And it doesn't specify the way the bits move on the wire.
So it looks like we have Ulrich next, and then Rainer has a question.
Just something very short. I'm just stepping in, Ulrich. I'm sorry. Larry, could you please make this slide available? This was also a wish of the audience.
Yes, of course.
If you send them to us, we will put them into the protocol. And
okay. You have a version without the builds, since I was worried about the screen sharing. But I'll send you the version with the builds as well. The builds are a little complicated because I like builds. Hi, Ulrich. What's up?
Hi. Hi, Larry. Yeah. There was a small shift in your explanations, which makes some hope for me with DOIP. And this was the one, the 8 slide. And there you said that the process to get the operation is a process which goes to the type registry or to some kind of service which gives the operations. And this is a bit different from what I've seen before, where the digital object itself have their information which operations they can use. And
okay,
so there is something more flexible now.
Well, there's another nuance in there which I didn't go into, but I will now. So the type gives you the basic set of what set of operations are possible for an entity of this type, and I would put that in the type registry because the implementation that you want that separate from the implementations, and the implementations may change. So if that is a visualization example, there might be 2 services that provide that service for that type of object, and then maybe a 3rd one shows up that's better. So you want to modularize that. You want to keep those 2 things separate. Another consideration, however, is that it is the repository which is going to have to execute that. You know, the object is just a virtual set of dead bits full of information, but there has to be an executable in there somewhere. And the repository may not be able to implement all the possible operations. And so it uses you would configure a repository if you wanted to constrain the type of operations it could perform. That's why I had the query go back and forth through the repository instead of just send the client off to the type registry.
But this also means that we need some kind of operation repositories somewhere.
Yes, we do. And that's, so as, I don't remember if this was before the session started or not. The key to this, to me, the key to the whole business is to start getting end-to-end examples up and functioning. Because to come up with the typology, if you will, and I wish we had another word than types because types is so overloaded, is going to be very domain specific, very complicated. And it's right up there for me with semantics, and I hope we don't, go down a rabbit hole of type ontologies and so on, because that's sort of endless. But we do have a lot of work ahead, and you know as well as anybody how hard it is to keep coming up with these sorts of examples.
Yeah, thanks.
So I would like to invite Stian to come back. I think we started to answer his base question about the HTTP protocol. However, from the chat, there seems to be an ongoing conversation about DOIP and linked data. So, Stian, do you want to?
Yeah. What I've been hammering on about. Don't forget HTTP. So it's good that message has come in, but I think there, it sounds like there is an opening for having other protocols as well. Maybe for efficiency reasons or security reasons, right? And that means you would need some kind of negotiation, right? Because that's what this sounds like here, right? You're talking about possible methods on the server, which may or may not be implemented. And then the same with the access protocols, right? Because you can't expect all servers to implement all possible versions of the abstract protocol either, right?
Right.
But we could sketch out what is the minimum. I would of course argue HTTP should be the minimum that everybody should expect, should implement, and the same for the types. There should be a minimum operation that everybody should support, like, I don't know, get metadata, that kind of thing.
Yep.
Yeah. And then you have the add-on extra bits and bells, right?
Yes,
maybe needed for more interactive scenarios.
We did some work on that with a pilot project that was funded by the NSF here in the U.S., and we did an implementation of the basic CRUD protocols, the create, read, update, and delete. I always forget those, but that was our base implementation, and then additional operations can be added on beyond that, but we wanted to make sure that we had those basics covered before we look towards more complex operations.
Now, I put a link to the spec. I recommend it. It's not a hard read in the chat. And in addition to the usual CRUD stuff, the basic operation, one of the basic transaction commands is list operations. Mm-hmm. And this is everything in the digital object world is a digital object. And so a repository is an object, and you can ask it to list its operations as well.
So Larry, it kind of came up, and I hadn't thought about this before. It's one of those from mix of the conversation and the talk. Does the then operation become a digital object also? I would think it would.
Yeah, it does. It has an identifier, and everything is an object. We try that. I mean, to me, it goes back to how I learned how to use Unix, and in 1847, or whenever I learned how to use Unix, everything is a file. So that's sort of a philosophy that we try to apply here. I don't know if it'll hold, but I want to start there. Everything is an object. Go from there.
And Reiner, you have a comment?
Yeah, first of all, thanks, Larry, for this introduction. I really like the idea of intelligent repositories which are able to handle and to evaluate and to make them actionable, the fair digital objects. But I'm also worried if I'm thinking about research data. We have tons of research data out there in legacy repositories. And we need also procedures, not how to convert and to put these data and transfer this data from an old repository in a new one, but to handle fair digital objects also which are located, or at least their data and metadata is located in old-fashioned repositories.
Yes.
And this enabling, for that we need to build up a workflow, how to enable it.
Yes, I agree. And that's there are many intellectual challenges, the greatest high-level intellectual challenges, but the most to get this done, I think most of the work will be at that level, the level you just identified, which is to take all this great variety, which is our problem. That's the interoperability problem, is the heterogeneity of the current environment. And to try and abstract a level above that is going to involve a lot of individual problems with mapping and so on. And of course, the problem with mapping is always losing context and detail. So no trying to sugarcoat that. It's going to be difficult. One of the reasons I got interested in the DISCO project, I don't know, Alex keeps liking to hear this statement, is I thought that the natural history domain, where the primary entity was a specimen, was a good place to start, because the granularity problem, although I've learned it's a little more complicated than I thought, but there's a nice easy answer to the granularity problem at first, which is, what's the object to identify? The specimen. It's the bug with the pin in it, or it's the frog. So that gets you a good start from my perspective.
Yes, it sounds like Barbara has a question about variability. Barbara,
yeah.
Please.
I just want to say, for this variability coming from the different domains, I think a contribution for identifying types of variables, so the typing of variables, we have addressed this in the IADOPT framework, because we see this necessity to have an interoperable approach across any domain. We are dealing with variables, and we would have a solution for that. And I just want to link you to the work we did for the last years.
Okay, so can you put a link in the chat?
Yeah, can I put a link? And I have put it also in the document, in the minutes.
So I don't know who put that.
Great, thank you. Let me see if I can find it in the minutes and put it in the.
Okay, so there's another question about, if everything is an object, everything needs an identifier. Many of these objects will be short-lived. Yes, true. Yeah, I think that's the answer. Is I assume at some level you will have identifiers that are ephemeral, just for the current transaction. But we have to try it. I would make a distinction between those identifiers that we believe will be there will be used 10 years from now versus the ones that won't. Peter?
If I may add something, so it's a bit a funny thing with the operations. So at the moment where you have a digital object, it's some bit sequence somewhere stored, right? And then it turns out to become something different when you execute it. And so we need to make this difference, I guess, right? I'm not quite sure how to do it, but we need to make this difference, since the digital object is the thing which is stored somewhere or so,
Yes.
and the operation is this thing being executed, right?
Well, the thing itself provides the data for the execution.
Right.
To me, files are an easy parallel. I mean, if you have a video, it doesn't execute itself. It's just a pile of bits somewhere. So you have to feed that pile of bits into something that turns the pile of bits into streaming video. I see no difference.
Okay, very, very good. Barbara, maybe towards the end of the session, if you can give us a little more detail about iAdopt, that might be good. It does. I'm looking at the slides now, but don't have time to review them. But maybe you can take 5 minutes in this larger discussion that we'll have later to
Yes.
to talk about that.
I just want to say I will present at the finalist poster presentation. So 4 minutes. It has been voted one of the best. So.
Very good. Very good. Thank you. And Larry, I know you have to run, and we have another presentation coming up. So thank you again for agreeing. It was a wonderful presentation and question and answer session. This, I think, will be recorded, so you can see what happens later.
Okay, very good. I'll look forward to seeing it. Thanks. I'm glad I didn't disappoint.
Thank you. And then we do have a video presentation coming up. It was suggested to us that everybody please make sure you're muted and your camera is off during this video presentation to stop any audio feedback. So I'm going to drop off now, and Reiner will get that video.
Okay. I don't know whether I have to open my mic for the video presentation. I will close it. If you don't hear anything, please send me the emoji with the horrible face.
Yeah, Reiner, we're not hearing any audio at the moment.
So let's try it again.
Hello, my name is Luis Bonino, and this presentation reports the current status of the work on the Fed Digital Object Framework. For the conceptual model part of the framework, the work has also the collaboration of Giancarlo Guizzardi. I assume that you are all familiar with the FAIR principles by now, of course. In RDA, this has been discussed for many, many years. Of course, to call this framework a FAIR digital object framework, it should be based on the FAIR principles. The FAIR principles give us a set of requirements, especially when you consider that they target primarily machines. These requirements include that we should have identifiers for both metadata and the objects that they describe, that we needed to separate metadata from other types of objects, that we should have clear and explicit relations between the metadata and the objects that they are describing, and that we should present at least our metadata in a machine actionable format, so that machines are able not only to read the metadata content, but also to interpret it and act on the newly acquired knowledge. In FDOF, a FAIR digital object is defined as a sequence of bits that represent a machine actionable informational unit. This means that not all sequences of bits are FDOs, but only those sequences that have an informational value by themselves. So they don't depend on anything else. Just by themselves, they represent some kind of information, or can convey information, or can produce some information, and that they are machine actionable following the requirements of the FAIR principles. Of course, larger FDOs can be composed of smaller FDOs, as long as the smaller FDOs that are part of a larger one have an informational value by themselves. An example would be a repository, which is an FDO by itself, and this repository contains a number of data sets or metadata, or whatever the repository contains, which are other FDOs as well. And this should be represented using some kind of containment structure that you can relate one FDO to another one using some specific relations that are relevant according to the situation. The main features of FDOF are that it defines a clear separation between object, identifier, and metadata. It provides a predictable resolution behavior. There is a mechanism to access the object's metadata from the identifiers, from the object's identifier. The framework defines explicit relations between the metadata and the objects they describe. There is a common metadata presentation format so that machines can read and interpret them. And it provides a typing or characterization system for the objects. Here we have simplified versions of the FDOF conceptual model representing some of its aspects. Given the time, I just selected some that I think that will be more interesting to present here. In this diagram, we have that there are entities that are able to be identified by identifiers of a given type, like PIDs, URIs, etc. Then we have fed digital object that's a specialization of this identifiable entity that are not, the FDOs are not only able of being identified by identifiers, but they must be identified by an identifier. And this identifier may not, should not be any kind of identifier, but should be a kind of identifier that presents properties such as global uniqueness, persistency, and resolvability. So if we don't have identifiers, we don't have FDOs. So absolutely required. Everything should be identified. Here we have the separation between metadata and the objects they describe. Of course, metadata is also another type of FDO. In the conceptual model depicted here in this diagram, we have metadata and ground entity as two specializations of FDO. We use this approach to avoid the infinite recursion that a metadata record as a proper FDO should have its own metadata record, which should have its own metadata record, and so forth. And using this, we can say that regular FDOs must be described by a metadata record, but a given metadata record may not have its own metadata. The typing system of the FDOF provides information about three aspects that can be used to classify a given FDO. The idea here is to provide information about how this object is presented through its encoding format. That's how it's done in a digital environment. So we need to have an encoding environment. Another type of information is what's the role that this object plays as an informational artifact. And this is provided by the informational entity type. And what does the object refer to in the world? To better understand this, just have two very simple examples. Of course, we can elaborate and have more complex with more elements, but just to give an idea, here we have the object X, which has the informational role of an image and is encoded in JPEG. This object refers or represents a party where John and Mary attended. So we have a photo of a party, and then we have John and Mary attending a party, which is an event, and so forth. In another example, we have the object Y, which is a data set encoded in XML and represents gene-diseases relationship. Regarding the FDOF predictable resolution behavior, we have two options. The direct behavior is that the identifier resolves directly to the target FDO. The assumption is that this is the most commonly expected behavior, especially if we already know the object and want to interact with the object repeatedly. Another point is that this direct behavior is equivalent to what's what's implemented in most current infrastructures like the web, where the URIs are normally used as URLs, meaning that they represent the actual location of the resource. So when you resolve URI, the identifier, that URI is behaving also as a URL, the location, and then the infrastructure, the web infrastructure, the internet infrastructure, resolves that to the target resource, that's how it's called in the web, using that location. The second behavior is the indirect behavior, where the identifier resolves to something called the FDO identifier record. This identifier record is a small piece of metadata that contains the references to the actual FDO, the FDO's metadata record, and to the characterization, so to the types and type system that we mentioned before. Having the identifier record, the client is able to get information about what type of object this identifier identifies, so what am I dealing with, and also, if it's necessary, how can I get more information? Basically, how can I get metadata about the object following the reference to its metadata records? As said in previous slide, the identifier record is a type of metadata that contains reference to the actual object, its metadata, records, potentially more than one, and the typing system. Here we have also a fragment of the identifier record in RDF. Thank you for your attention, and if you want to discuss this subject further, you can contact me. In this URL, I'm gradually writing down these ideas about the different digital object framework. As a disclaimer, so don't take that as a set in stone. This is our ongoing work, and the text in this URL is not always up to date, because first I try to work on the concepts and then test and discuss with other people. Then once this is a little bit more mature, then I write down. But I'm trying to work on some of these aspects and as quick as possible write them down here to make it available immediately to everybody. Thank you. Hello.
Okay. Great presentation by Luis. I had hoped that he would be here to fuel this discussion and answer questions, though I think there are several people here who, one, have been involved with this work, but in general can continue this discussion on linked data and the Fair Digital Object Framework. So I'll open up now, and we do have discussion for pretty much the remainder of this session, other than a quick wrap up. So we have some time for discussion. If anybody has questions or comments, now would be the time. Without any immediate questions or comments, this might be, I see Alex has come on. Alex, do you?
Hi,
Alex.
yes. Yes, so this is the first time that I've seen this presentation from Luis, and it's very interesting and very thought-provoking, and there's a lot to see in it as well. I think it is worth making the point that in the work that Luis is doing, he's showing here an attempt to link together this new level of abstraction that Larry talked about in the previous presentation with a specific technology implementation that's orientated towards the World Wide Web and the current protocols and linked data approaches that are being used there. And what I wanted to highlight was that, and I think Larry would have done the same if he was here as well, is that this new level of abstraction that DOA offers can have multiple mappings to multiple different kinds of implementation technologies, just as we implement much more specific implementation technologies and implementations on top of TCP/IP and that suite of protocols. You can see the same kind of thing happening here. And it's worth pointing out that in the the context of the Fair Digital Object Forum work that that Larry introduced, we're working there. Lewis is working there in one of the working groups on this piece of work, and then in one of the other working groups we're trying to take what we call a native mode approach to implementation of DOA using the DOIC protocol. But what's important is that this Fair Digital Object Framework has to be cast in terms of a core specification that can be used and adopted by more specific technology implementations, and that's one of the first outputs that we're aiming to produce as a forum.
Great, thank you, Alex. And I do have to say, from both Larry's presentation and Luis's, this really doesn't. There's no additional components to the digital object architecture as envisioned. There's additional metadata defining relationships, but there is not. This does not take additional services. It's still basically a handle service, a resolvable handle, a typing information, and then that mapping information and a protocol. So there's no new components that we haven't been looking at for quite some time in various different implementations. So other questions, thoughts? Peter, do you want to introduce that the basics, the definitions that we've produced through the Fair Digital Object Forum?
That's fine. Yeah, that's fine. Can you hear me?
Yes.
Yes.
Yeah. So that's fine. So just to confirm what Alex said and Luis said, so before the Paris meeting, which was mentioned by Larry, Luis and myself sat together basically, and of course chatted with others, and we came up with a definition or specification of the first specification of the FDOF, which you can find on the GitHub side of GIDE, which is another collaboration. So if you are interested, and you will see in this FDOF specification exactly what Alex pointed out, that we have at this moment, or identified at this moment, two implementation ways, one LDP based, one DOIP based. And there may be others, since we all know that different technologies will come up. Mm-hmm. So that's just my 2 cents.
Okay, thank you, Peter.
There are also other questions in the question and answer section. So, Wouter, do you want to repeat your question? So, oh, here he is.
Yeah, it always takes a few seconds for that the camera and/or a microphone to come on.
It has already been answered, Rainer.
So you were asking if everything is an object. Would you like to repeat your question or your remark?
Yes, my question was about the persistence of identifiers for the objects. That was already answered by Larry. So I asked whether if everything is an object, then everything needs an identifier. So many of these objects will be short-lived, though. So they do not need an identifier that is persistent. So should we also use handles for these short-lived objects, or should we make a separation? And I think the answer from Larry was that we should make a separation there.
Thanks. There was also a question by Sharif.
Sharif, do you want to unmute and ask that question? It's always great to hear new voices.
Yes, so I was curious, how would you think the world dominated by Google and Facebook will use, things like Fair Digital Object that we are talking about in our little corner of the world?
So I do know that there are some implementations outside of academia. There are some implementations in the motion picture realm of identifying various different media related to a larger production, and it's also being used in the construction business. Though I haven't looked at the details, so I would think that it's just as important in outside of academia as inside. However, that's a little bit beyond our view, and there's always going to be, as you said, we have a domination of Google and Amazon's and various different data structures, and whether it moves into that realm, whether they grasp this or create something similar or have already created something similar that they use internally is at least unknown to me. So do others have thoughts on that, on the use of FDOs outside of academia?
Yeah, perhaps from my side, I would assume that this is not directly in the interest of Google and Facebook and the others, because they are working in silos and they are using whatever they can get, but they are essentially working in silos for themselves. And this technology is more in the direction to overcome silos. So there is a political issue, of course.
And a commercial issue.
And a commercial issue, yeah.
Okay. Alex, you had, I don't know if that was a comment or a question, but I see you.
No, it's a comment. I wanted to come back on the question that Wouter asked about the lifetime of identifiers. And I think you have to separate the technical mechanism which you referred to, which is the handle system, which says nothing at all about how long a handle should live for. You can have a handle that lives for a long time, or you can have a handle that lives for a very short period of time. It's up to you when you create it and delete it. The length of time that you need a handle for, which is related to its persistence, of course, is a matter of the policy and of the application domain that you're using those handles in. And I can think of multiple instances, within single application areas where, you want to create persistent identifier, or you want to create identifiers for fair digital objects which have persistences for different lengths of time, some very long, some very short.
Yes, agreed. And it's easy enough to give a lifetime to that digital object within the metadata, right? To make it a result, the lifetime be something that is a resolvable metadata field. Peter, you had the next hand, I think.
Sorry, I was asking how this is related to row crate, RO crate, research object crate. I would like to know more about that. This approach of fair digital objects, is this somehow related to research objects crate?
So I'm not aware of RO crate or RO crate.
Yeah, but maybe Stian is able to answer this question. He's here.
He actually had to leave, I think.
Oh, sorry.
Perhaps I can answer it. I can't claim to be an expert on RO crate, but certainly within the context of the distributed system of scientific collections, the DISCO research infrastructure, we're engaging with Stian and his other colleagues responsible for RO Create to understand exactly the relationship between it and fair digital objects. And I think at this stage we can conclude that an RO crate is it can be a specific kind of fair digital object. It meets a number of the requirements that, for example, both Larry and Louise set out for fair digital objects. But it falls squarely into one of the implementation approaches, namely the linked data platform approach.
Mm-hmm. And also thanks to Zach, who pointed out that RO crate with Carol and Stian. They gave a talk about the RO crate in our digital objects or in the Data Fabric monthly meetings. And Zach also put the link to the recording of this presentation into the chat. And I remember we had a good discussion about bag of pointers.
Very good. And Ulrich, you're saying something about you have a special prefix for short-lived handles?
Just one prefix. It's a convention we have that every short-term or short-life handles have to be in a certain syntax of the prefix. So there is a T after the dot, which means that these handles are for short-lived. To essentially to know that these are not assumed to be persistent.
Yes. So we did something very similar, Ulrich, in the Rapid project where we put started them with tests to realize that this was a test bed project and that these, while it was, they did look like persistent identifiers, that the lifetime of them lasted as long as the test bed and no longer. So they weren't to be used as persistent identifiers. So other questions, comments? I'm flipping through the tabs here. I don't like having to have multiple tabs where comments and questions and various things come in. I wish they would all come through a single channel. But Maggie, I would encourage you to add to the conversation by turning on your camera and your video. I think it's always better to have always better for the discussion.
Yeah, sure. So my question or my comment here was that yes, it's fine if the digital objects themselves might have a lifetime, and then either they are removed or they might still linger on, but there is no guarantee that they won't just be gone in an instant after some point in time. But we also need to remember that at least for some digital objects, the metadata about them needs to live on for a long time, because otherwise you cannot resolve questions that might come much later on. So that would, I think, really go for data objects that are associated with an article, for instance, and cited in an article. We can't just cut off the link there to that this object existed at some point in time. It was this and this and that, and this is the reason that it is now sadly deceased. Yep. I don't know what the comments on that would be.
Yeah, and that's very important for the reuse part of FAIR, right? So if you're trying to reuse something, even if the object itself does not any longer exist, you still need some metadata record of what happened when that object did exist, which can be then resolved via the PID.
Yeah, and I also think that when we were discussing during Larry's presentation or after that about this need to identify the transactions or the actions that are being taken, I think some of those may also need to be preserved for a longer period of time if it has something to do with provenance. So if the action is to process the data further, you go from raw data to some kind of research output, and that needs still to be recorded, and it should also be possible to find out later what was done. So the more complicated the capture of provenance gets, the more automated it is, etc. That's great, but we don't want to have an automated cleanup system which just cleans everything at midnight every day. So there also needs to be some way of labeling different activities and keeping a record, I guess, in their registry kernel metadata that it's okay to delete this, or this is the lifetime. And all of this is adding, I think, more and more complexity to what the registries in this whole puzzle, what they need to guarantee. And the question I always like to raise is, what about sustainability? Who is paying for this? Who is making sure that this metadata is really stored in multiple locations, so that if a dictator grabs hold of a country and presses delete for all research because they want to make like a cultural revolution type of thing, how does the rest of the world manage with this? And so governance is very critical here. Money and resources is critical in my mind, and also, of course, the continuous training of all the different partners in this, from data producers, repositories, registries, and end users.
Yes, that training is an important question, because I think right now the training material on fair digital objects, or even the digital object architecture, is something that you really have to search for, and is really hidden, and just a base introduction videos, which I hope to produce as part of the Rapid project before it closes down in October. It just, a general introduction to the public of the digital object architecture and fair digital objects is something that is missing right now. You have to really search multiple web pages and dig into the details. And Rainer, you have a comment there?
Maggie, thank you very much for your comment, but you also frightened me, because if we, I think we have to keep the principal ideas of the fair digital objects very, very simple. So not everybody might agree, but for me, a fair digital object is an identifier plus an ambiguous defined information record. And this points to other information, and the information exists or not. So, but the core of the, so if I'm just looking at research data, the core pointer to the research data exists. Even this metadata in the information record exists, even if the original data is not longer accessible, like you described in the FAIR principles. But I really, really like to keep it simple, and then what we can enable with these fair digital objects, if we use all the possibilities, then of course it's getting complex. But this is then the task of the systems which are using and using all the possibilities in fair digital objects, but not of the object itself. But this is my interpretation. Others might disagree.
Okay, Rainer, so can I just clarify to make sure I understand? So you said an identifier and an unambiguous information record that points to all of the parts of the object, the thing that make up the object. So in your mind, the FDO is just the identifier and its handle record. Is that correct?
One interpretation, yes. That's my simple interpretation.
I'm not saying whether I agree or disagree, but I just want to make sure I understand what you're saying. Thank you.
Okay. And Peter's brought up an important point here that for those who aren't aware, PID is incredibly cheap, right? So both minting a PID and resolving a PID are incredibly cheap operations. Now, incredibly cheap operations do not stay incredibly cheap when we're looking at potentially billions of these happening at a time. However, at this point and at this stage of complexity, the PIDs are incredibly cheap. And Peter, you want to elaborate?
Well, on the Rainer's issue, so Alex was very, how do you say, nice to Rainer, but I would say no, the PID has a record or a landing page in the LDP version, and that points to components which are part of the FDO. Of course, an FDO should have, if it's not deprecated or so, should have a bit sequence, of course, right? So some encoded content, and it needs to have some metadata. I think Maggie pointed that out. So these are all parts, content or parts of the fair digital object. I would not say the fair digital object is the PID record or so. No, the ISBN number, if you want, points to a work or, you know, some abstract kind of work. But, you know, it's meaningless, an ISBN number, if there's no work behind it, right? So I don't speak about the copies of books, which are in thousands of shelves, but about the work itself. So PID will be assigned to something which is real, which is a bit sequence containing some information. Could be software, could be data, could be metadata, whatever. I guess we agree here.
I think this is always as a problem, or especially by my very practical understanding problem in fair digital objects. Whenever somebody tells me we have an entity, for me the entity has borders, and I tend trying to identify the borders really very clearly. I want to know what is inside, what is outside. So just as a justification.
So I agree completely with Rainer on that remark. When you identify something, it has to have a boundary, what is inside and what is outside. And this has two consequences. One is that knowing where that boundary is tells you what to put into your specification of a fair digital object and what to leave out of your specification of a fair digital object. Because, you know, if you take the opposite view to Rainer, at the other end of the spectrum, you have a fair digital object where the PID record is outside of that boundary. And so you have no requirement relating to the PID record in the core specification. The other consequence it has is when it comes to conformance testing. Where is the conformance testing point, and what are you testing, and what are the tests that you apply? So it is important to know where this boundary is.
Yes, may I continue on that? The question where the boundary is becomes especially difficult if you are working with references. And all the thing we are doing here is the abstraction essentially is we are making references. And that means that at the end, we can say the boundary is somewhere else. Nobody knows, or it's up to you. The reference is that what is interesting. And in this context, actually, I would agree, Rainer, to say, well, it's just the header record. Because all the references and the references below that are in there.
But then, if I may add here, then we are far away from what Luis explained, right? We're speaking about fair. And if it's just if the boundary is the PID and the PID record, the resolution, if you want, so depending on what kind of technology you're using, then the only thing you need to check is the fairness of the resolution result, right? And that would be very crazy, since you know, fairness would mean somehow that your object itself is fair and your metadata is fair. Since otherwise, you know, the check on fairness is trivial, right? It's in the kind of in the case of PIDs or DOIs, it's almost trivial, since you know you specify the attributes which occur in the record. Well, then you are done. It's fair. No, that will not be sufficient, right? The object itself, so the bit sequence is associated or contained with the fair digital object. That has to be fair. That has to be accessible. Otherwise, the whole term of fair is nonsense.
Maybe the some part of the discussion we started now is a bit academic. So for me, a fair digital object, this is a name. So we have a definition of the fair digital object, and then we have a kind of a boundary. It doesn't depend where we lay it, but it must be something reproducible. Then we have the check whether the fair digital object meets all the specifications. That's something else for me. So the question is, in this case, does the full specification also belong to the fair digital object itself, or does it just specify features, required features or mandatory features and optional features? But I think this discussion we won't solve today. But I like it.
And there will be a lot more similar conversations as we move forward and as the Fair Digital Object Forum and this group continues. So we do only have about 10 minutes left. I would like to give Barbara a chance to at least briefly introduce iAdopt for those of us who are not familiar with it. And Barbara, if you can keep that to less than 5 minutes so we can then wrap up and get any action items or anything that else we need from the meeting. Please do. And I did see some other people were very interested in this.
Thank you very much. Should I share a presentation? So this is now also a possibility to train for the 4 minutes presentation that I will give in half an hour. Should I change it? Should I share my screen? Is that okay?
If you'd like. Yep.
Yeah. So I don't know if you see it. Do you see it?
Yes.
Okay. So this is my presentation about the first version of the iAdopt framework, which is now open for comments. And this is the outcome of the RDA working group interoperability of observable property descriptions. And this is a working group that's now in the latest stage. So in 2 months, we have to publish and come out with guidelines how to use this framework. So we are focusing on variables, and variables are also known as observable properties, so traits or parameters, and they are used everywhere, but we think that the description is very often very fuzzy, ambiguous. But variables are really important because they give the meaning to the value derived from any type of data acquisition, be it an observation, a measurement, a simulation, or so. And so this group supports only the classification of types. This is why I mentioned it, because you talked about typing, yeah. Mm-hmm. And we do it this way because we think that a variable represents what has been observed, measured, whatever, but independently of where, how, and when the data acquisition took place. And this makes it reusable in different settings. So the problem that we see is that we have tons of variable descriptions out there in linked data in different vocabularies, but they are not mapped to each other, and they are so different in description. So we are targeting this issue, and the iAdopt framework should help to support the interoperability between the descriptions. And the approach is to decompose the description in atomic components and link those atomic components to existing vocabularies, and thus we can make them machine readable. And also precise, describe them semantically precise. And this enables us to make mappings between these descriptions across terminologies without changing the original structure of the source, but just by adding mapping relations. So what we did is we identified components, brought them together in a framework by identifying the relations, identifying the terminologies that can be reused to populate these framework components. And these terminologies, we have them from quite a vast survey we did last year, so we gathered 100 terminologies. that can be used. And then we also push or promote the mapping between the terms in the different terminologies to each other, like habitat, as you can see, pop up everywhere. And then by this and the IADOPT framework, we are confident that the variable description in one vocabulary can be mapped to another one in another vocabulary. And I'm now going to present just very quickly what is the framework about by one example, this concentration of chemical contaminants in biota. What is needed is, first of all, a property and an object of interest. So the property here is the concentration per unit mass. That's a property of the object of interest that is studied. In this case, it's endosulfan sulfate. And this is measured in a matrix, that's the flesh of a species, and that's in this case Ostrea edulis. The matrix, the flesh, it has a constraint. It should be wet and not dried. And all these components have links to existing terms in with URIs, with permanent URIs for these descriptions. So this is how this could look like in a SCOS implementation. We would suggest to use SCOS extended relations to really describe this in a machine readable way. And this is how this observer property or variable concept can be included in a wider context. So a result value deriving from any type of data acquisition event, like an observation, simulation, calculation, should always be linked to a variable description and also a unit if it is a quantitative result value. And via the unit, it should be consistent with the dimension vector and then also with the quantity type that is used to express the property. And yeah, we have here modeled different examples from different domains, Earth observation, life sciences, social sciences, and biodiversity, and also climatology. So you can have a look at that, or also at our poster, where you find all the links to the resources we produced. And we would be very happy to get feedback and also improvement suggestions, because we have published it now, but it's still something work in progress, and we are happy to improve. I think it was helpful.
Thank you, Barbara, and thanks for doing that ad hoc. And I know you weren't prepared to do that in such a short form. And as you probably have not read in the chat yet, it would be great if you could come back and give maybe that full presentation at one of the monthly meetings of the group, and we can really kind of dig into it and have some discussion around it. And Reiner?
Maybe I have time for a short commercial. Because in our Fair Digital Object group, or here in the Data Fabric, we run monthly telephone conferences with project chairs. Barbara, we would like to invite you to give a full presentation. One of the next presentations, the project chairs, they take place at every fourth Thursday in the month at 1500 UTC. And one of the next presentations will be the Fair Digital Object Testbed, presented by Thomas and Andreas about the Helmholtz Metadata Collaboration Platform. We are talking about topics about the EOSC interoperability framework. We would like to invite Zachary Trout to show us the materials use case, Ingshen about linked data network, and many others. And we would like to invite you. Back to Rob.
Yes, thank you, Reiner. And that's one of the things I wanted to cover here in this last few minutes. It was a wonderful discussion, and I want to thank everybody. This group always has a very active discussion. I think that our conference here may cut off in a little less than 2 minutes. So are there any specific takeaway action items outside of scheduling a few things for the monthly meetings and then continuing these discussions not only here in the Fair Digital Object Fabric interest group, but also in the Fair Digital Object forum, which we've put that link in multiple times, and I I look forward to having an entire week that we can talk about these things during our spring conference that is being planned, because I think that an hour and a half every 6 months is just not enough to get to the bottom of many of these issues that are being raised. So thanks again, everybody. And I look forward to talking to everyone again soon in whatever forum we find ourselves in. And I did that with 50 seconds left. So any final comments, Rainer, or anyone else?
Thanks a lot.
Yeah, thanks, Rob. Thanks, Rob. And thanks, of course, to the audience.
Yes, absolutely. Okay, and we'll see you. I guess the plenary section, the final plenary is coming up later today or early tomorrow. Actually, I need to look at the schedule, but we'll talk to everybody soon.
Thanks. Bye.
Bye. I'm actually going to see if it does cut off immediately at